everyone. Super welcome to this Thursday afternoon. Thursday, you know, the day before Friday. I don't always know which Friday, but hey, this is the day before tomorrow. Zalnay, welcome, sweetheart. Welcome. Miss P! All my normal people. I'm seeing some new faces. I really like that I'm seeing some new faces. Guys, we also have a very special guest today. One of our grade 11 teachers has to go back to school. She's a grade head, so she has to start next week, Monday. So we've been very fortunate to get Mr. Sabia to take over her classes. Mr. Sabia is like, oh, he writes the nicest maths and things guides. So we are so fortunate to have him on the program as well. You guys are going to miss him. I'm sorry. My bad. But you still got me. Okay, so I've invited him to join us today. Okay, just to kind of see how I do things. Okay, so that you can kind of get an idea of how I deal with you. Oh, no, Miss P, calm down. Wait, calm down, Miss P. I am not leaving you. Your maths teacher is not leaving you. This is for grade 11. Calm. Don't panic. Okay, everybody's okay now. Oh, we almost caused mass hysteria. Oh my goodness. Come on, hello, how you doing? All right, guys, so just a reminder, I need you guys to keep your mic muted. There we go. Problem solved. Nelly. Hello. Tino, hello. Zalnay, World War. Oh, I love that. Okay, guys. So yesterday we spoke about Viva la Resistance. Okay? We spoke about resistance. And we kind of got an idea of what resistance is. No? But today, and yesterday we started with it because we had some time left. We started looking at series circuits. Okay? So today we're going to recap yesterday's series circuits. Okay? And then I'm going to switch over to the ever famous whiteboard so that you guys can laugh at my ever famous squiff writing. Okay? And then we're going to draw a couple of series circuits. We're going to do a few calculations with them. Okay, so today is all about series circuits. Okay, so in the Oxford, I have got it on not page 1. Forgot to finish the typing. Page 170. 170. I'll correct that before I put it in the drive. Sorry. But what I did do is I guesstimated that in the study and master, it's going to be on like page 108-ish. Okay. And then Miss P, just for you, Doxki Enza, I think you're going to find it on like page 163. The topic you are looking for, guys, if you want to follow in your textbook, is series circuits. Okay. Now, as always, guys, remember, I condense the stuff. Oh, thanks, Poppy. Like, I overestimated. Okay, I'll fix that. Hang on. 204. Got it. Right. So, thanks, Kamal. I guesstimate. You guys know that. I don't have a study and master in my hands. All right. So, as always, I am going to condense the work from the textbook for you. I'm going to show you guys what's important, what I don't think is, right? And then, because I believe that electrical circuits are practice. Miss P, I I got it right. Oh, that's so cool. Thank you. Okay. So because I believe with electrical circuits, it's practice, practice, practice. Okay. That is what we're going to spend a large amount of today doing. All right. Don't worry. I've got you. Guys, when we started with this, Tyrese, we're busy with series circuits. I'm glad you could join. You're going to owe me 10 virtual push-ups for being late, but we can deal with that. Okay, so electricity is practice, practice, practice. When we started with electrical circuits, everybody in this class went, no, nemesis, hate it. And now we've gotten to a point where it's not quite that bad. Hey, guys? Okay. So please just stick with me. Okay? Oh, okay. No worries. Reseto. Right. Is that better, Corley? Better. Okay. Cool. So, you guys keep on breaking my train of thought. Let's get into the work, shall we? Okay. So, the basics, and this is a repeat from what we did yesterday. Remember yesterday, just before this point. Okay, Miss B, I'll change it. Yesterday, just before we got this to this slide, remember I said if you are sorted and comfortable and you are with me up to this point, you are good and golden. Okay, remember that? So today we're just going to go back to what I said about series circuits. Okay, now we already know that electrons are a little bit stupid. They're a little bit like sheep. They just follow the herd. And when we build an electrical circuit, we show them which path to follow. With a series circuit, they have no choice. The electrons can only follow one path, okay? They can't go anywhere else. They don't have options, okay? So one behind the other, in Afrikaans we'd say ingelit, one behind the other. They follow each other through this electrical circuit. Okay, so that is the idea. Tyrese, we're in the physics side of life. Okay. Okay, so, but yes, Tyrese, Miss P says it's 148 in Doxkienza. Okay. So we said that if we have a series circuit, the electrons can only follow one path. All right. Now, yesterday we did this too, and we said, well, unfortunately, we have to think about the rules, okay? And I can guarantee you these rules are in your textbook. They're just paragraph after paragraph after paragraph. Thanks, Deirdre. Deirdre. Whew, brain. Okay, so the rules. The current everywhere in a series circuit is the same. Remember, current is the flow of electrons. It's how many electrons flow through a point per time unit. So if they all have to go one behind the other, they all have to go at the same speed. Okay? And so the current is the same everywhere. Okay? Then we said that the potential difference splits. Each component, Tino Doxkienza is a textbook, just like Study and Master and Oxford and Platinum and Via Africa. Okay. We then said that each component takes some of the energy. Okay? And we said that each component's energy has to be equal to the energy that the battery gives. Can't be equal to more. Battery only gives a certain amount of energy. That's it. When you drink your Red Bull, it gives you a certain amount of energy. Your body, each component in your body has to choose which part uses what amount of energy. Okay, so it's exactly the same in a circuit. The electrons, depending on how much work they have to do, lose or transfer energy to that component, and then by the time they get back to the battery refills that energy. Okay, right. Then we said from these rules, we have a little bit of maths. Okay. So the maths, the current is the same everywhere. The voltmeter readings is equal to the voltmeter reading over the battery or across the battery. And if I want to calculate the resistance, the total resistance, when it's a series circuit, all I do is I add all the resistance together and I get the total resistance. Okay, so this we looked at yesterday, okay? And remember I said I know that this is hard. I know that it seems confusing, okay? But that when we practice this a number of times, it becomes easier. Okay, so it is currently 10 minutes past 2. That gives us at least a whole 30 minutes to practice. Okay, now we all know how much I love to hate PowerPoint. So let's switch over to the whiteboard. Viva la resistance! Yes, Tyrese, absolutely. So we're switching over to the whiteboard. Ta-da! All right. Viva la whiteboard, Erin. Hello, Erin. Okay, so guys, I've said this to you guys before. I am a big fan of the Oxford textbooks. Hello, Erin. So most of the examples I use come from there. Okay? If there are of you that have study and masters and you try these problems and you either don't get the answer in the textbook because some textbooks are stupid and they give you the answer, or you get stuck, okay? Then next week is the week where you tell me that, okay? Now, Miss P, you're a few with a Doc Scienza, okay? But I think I might have slides from one somewhere, okay? But if I can't find it, Miss P, you guys might just have to take a screenshot and email it to me, okay? But guys, this is now the point where I'm going to show you how I would approach a question. And then if you have a different question in your textbook, yes, Tino, Platinum, I also don't have. I have the Platinum grade 11 on me, well, at home, but I don't have the grade 10 one. Okay, so guys, I'm saying to all of you, once we start practicing now, and if you then try and practice at home from problems in your own textbook, and you get stuck, okay, the answer series is also quite cool. Then I will gladly, I'll give you guys my email address. You just need to make the subject very clear so that I can find it between all of the others. And then I will gladly take that problem and we can practice it. Okay, so I really want you guys now to realize that I'm going to show you guys a couple of examples. We're going to try a few examples in class. And then I want you to go back to your textbooks and try those examples. And if you get stuck and your textbook doesn't have a memo or something in the back, okay, to help you, I want you, please, 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 to take a photo or a screenshot, email it to me, okay, and then we will work through these together, Okay, even if you don't have that textbook, then maybe you can see how different people ask it in different ways. Okay, so let's draw a very simple, not stupid, uncomplicated, that simple. Miss P, that's quite cool. I appreciate that from teachers. Ooh, no. Sorry, that was me trying to show someone like first year chemistry earlier today. Okay, so we're going to draw a very uncomplicated circuit. It is going to have in it 2 cells, right? And it is going to have an open switch, and it's going to have 2 resistors. It's going to have a 2 ohm resistor, and it is going to have a 3 ohm resistor. Okay, so very, very uncomplicated circuit, just to get our teeth sunk into it. And then the other piece of information they give me is that they say when I put a voltmeter across the battery and the current is open, the switch is open, I have a reading of 10 volts. Okay, quickest fingers first. It's an open circuit. So what do I call this measure? It's a very specific 3-letter shortened thing. Yes! EMF. Fastest fingers first. Erin got it there. Woohoo! Okay. So when we have a voltmeter and it gives us a reading and the circuit is open, we call that value the EMF, the electromotive force, and that tells us the maximum amount of energy that that battery, that cell or these 2 cells, so this battery can give the circuit. Okay. So the first question that they ask, Carolina, we have done electrostatics. We haven't done magnetism. The reason why I focused on important concepts in electrostatics was to bring them to electrical circuits. And then the reason why I skipped magnetism is because we can do it as a unit on its own. Okay. So, Carolina, you can go and look on YouTube. Guys, it was last week and Thursday. No, it was last week on Wednesday that I fell into your class the first time, hey? So, was it? Yes. So, no, I lie. Last week and Thursday, hello, Ali, Carolina. Last week and Thursday's lesson is about electrostatics. And then from this week and Monday, I started with electrical circuits. Okay, but I have not done magnetism. Okay, so the first question, they want to know the total resistance. That's the question. What is the total resistance in this circuit? Carolina, if you don't come right, please just let me know, and then I can potentially find that video for you, and I will send you the link. Okay. Right, so Ashley says 5 ohms. Miss P says 5. Okay, guys, so remember, for a series circuit, we add the resistance together. Good job, puppy. So we can say 2 plus 3. Luckily, I don't need a calculator for that. I don't know about you guys. So I get 5 ohms. So remember, for a series circuit, I just simply add all the resistance together and then I get the total resistance of this circuit. Okay. Now, we are asked, man, must be right ohms, we use the sign, Miss P. This sign here is the Greek symbol for omega. So you may write this the name out. So you could write ohms, ohms like that. Okay. Ollie, don't panic. You will understand parallel circuits. Don't panic, dude. Don't panic. Don't get ahead of yourself. That's tomorrow's worry. Okay, let's just do this today. Okay, so Miss P, you can write the word ohm if you want to. Okay. I prefer to just use the symbol. Okay. No idea where they came up with that symbol, but you know, trust the powers that be. Okay. The next question is a little bit tricky, but I'm going to lead you there. Don't panic. They want to know, the next question, what is the current in the circuit? Now I'm going to remind you, we have two formulas that have current in it. We can say it's the flow of electrons per time unit, or the equation we did yesterday, resistance and volts, we can calculate current. Okay. Aha, Aaron, my man. Aaron is 100% correct. Aaron says the current in this circuit will be nothing because the circuit is open. So, that was a proud moment. Oh, very, very impressive. Well done. Well done. Super, super, super work. Okay, so guys, in this diagram, the circuit is open. It's broken. The sheep electrons are going to get here and then go, I don't know. Okay. And because these sheep can't move anywhere, all the sheep behind that sheep will stand still. Okay. And then all the sheep will be standing still. Okay. So no current will flow. Aaron, super. Now, what do you think is going to happen when we now close this? Ooh, that's a very squiffy line. Oh well. When we close the circuit. Once we close the circuit, let's assume that the cells have no internal resistance. So now the EMF is going to be the same as the terminal potential difference. Okay, right. I'm just trying to think how's a nice way of putting this. In this first question, we calculated the total resistance. Everybody okay with that? This question here, we calculated the total resistance. In the second question, we are asked for the current. Okay? So basically, the question is, if I whacked an ammeter anywhere in this circuit, dunk, what would the value on that ammeter be? Ashley, mooi man. Sure, that was good. Well done. Okay. So, the current we are measuring here is the total current. Guys, all with me. The current I measure anywhere in the circuit is the total current. Here, we have the total resistance. What is this 10 volts? This is the total potential difference. So can you see we here have total potential difference and we have total resistance. And we can use total potential difference and total resistance to calculate the total current. Can you see how careful I have to be with that? I have to make sure that I'm working out the same thing at the same time. Okay, that's quite important when we work with circuits. Okay, again, guys, you can manipulate this equation. You know what I feel about it. Braden, the difference between current and voltage. Braden, current is a measure of how many electrons pass through a point at a specific time. Okay, so current tells me the flow of electrons. Voltage tells me how much energy can an electron transfer. Okay, so voltage tells me about energy. How much energy does the electron have? And, whoops, sorry guys. And current tells me how fast they flow. Now they are related, okay? They really are related. But you need to just make sure that you know the difference. I'm just quickly going to do the maths in color. Remember, I want to get rid of this I. Oh, it's my pleasure, Braden, as long as that makes sense. 10 divided by 5 is 2, and it's in ampere. What did I say? Are you not allowed to write here at the end? Which 4 letters? Amps. Thank you, Erin. I will come and find you. You either write out the entire ampere and you think it with a R in your head, or you write A. You do not write amps. Okay? Do not. All right. One last question on this current. And then I'm going to give you one and we can see if we can play with it. All right. Is that okay for you guys? Not too small. All right. Ashley, no, that's not the correct formula. So Ashley, the formula is, oh goodness, sorry Ash, sure. R equals V over I. So if you want to manipulate it, okay, you could write it as V equals I R, or you could write it as I equals V over R. Okay, these three are all the same. If you forget, if you struggle, use the triangle. Okay, if I want to calculate I, then it's V over R. Does that help? Okay, I really like this triangle, even though you do get this formula. Okay, this triangle does help orientate you if you need to calculate something else and not R. Okay, all right, guys. So I want us to now imagine we want to know how much energy does this 3 ohm resistor use. Remember, the total resistance that this battery gives to the circuit is 10 volts. So this 3 ohm resistor is going to use something less than 10 because this 2 ohm resistor also needs some energy. Okay, so if we add the energy that the 3 ohm uses and the energy that the 2 ohm uses, those 2 voltmeters will get a value of 10. Okay. So, right guys, I'm glad you sorted out your face. Let's work with me. Okay. I want to know that voltmeter reading. So I'm going to just shift the whole thing over, okay, because it's getting a bit much. You guys know me, my board skills are horrific. I have a 3 ohm resistor. I want to know how much energy does it use. Remember the ammeter we figured out here that was 2 ampere? That is the size of the current everywhere. Good, Larissa. Super answer. Everywhere in the current. Okay, this 2 ohm that we calculated over here, the 2 ampere, that one there, we said that was 2 ampere. So we've got 2 ampere of electrons, 2 ampere of electrons, 2 ampere of electrons. So when we are looking at this 3 ohm resistor, we can say that 2 ampere of current, yes, Corley, 2 ampere of current goes through it, and it has a resistance of 3 ohm. So we go back to this equation. We want to calculate V. Again, guys, you can manipulate it, okay? Please don't think that just because I don't, you can't. I just formed habits. I want to get V on its own. I've got that 2 there at the bottom. That's a problem. What I do on the one side. Come on. What I do on the one side? Maths. What I do on the one side? I do on the other. Thank you, Doris. I almost thought you guys were going to let me hanging there. Okay. So that 2 and that 2 cancels out. 2 times 3 is 6. Well done. Okay. All right. So let's just compare what I did here. Okay. Because this is a very, very important concept. Okay. Thank you, Tyrese. I appreciate you never leaving me hanging. Appreciate it. Let's just look at what I did and the difference between what I did. Okay. In this first one, I got asked to calculate the current. Okay. When I looked at what I had the total resistance and I had the total potential difference. And I know with a series circuit, the current is the same everywhere in the circuit. Unless, like Erin said, you forget to close the switch and then it's nothing. Okay. So I could use total potential difference and total resistance, and I could calculate the total current. With the last question, with number 3, they didn't ask me for total potential difference. They just asked me for the potential difference over this 3 ohm resistor. So now I can't look at the big picture. They're not asking me for the big picture. They are only asking me for this 3 ohm resistor. Okay? And so I isolate it. I only look at it. Okay? And so I go current through it and voltmeter over it. Yeah, Carolina, this is something that I really do think you guys need to, sounds so weird to say it, but just get used to, okay? If you write down a formula, and this counts for grade 10, 11, and especially for grade 12. Remember, guys, I'm teaching you skills now that you can take forward to grade 12. I'm not trying to just teach you skills for now. That's useless, okay? Because if you're taking the subject now, I'm hoping that you'll take it next year, and I'm hoping that you'll take it into matric. And so we need to teach you skills now that you can use and learn now that makes writing your matric paper so much easier. When we mark matric papers, and I can say we because I mark for the Western Cape, I've marked for the last 3-4 years. Oh, I'm not keeping up brain anymore. Okay. So I know that when we mark, the mark is given for the formula as it is on the information page. That is the directive when you mark. The formula as it is on the information page, the correct substitution into that formula, and then a mark is given for the answer with correct unit. Okay, so that is what you get marks for. You don't get marks for the maths. It's not a maths paper, it's a physics paper. Although, let's just be honest, it's just like, you know, maths and word problems. You get a mark for the formula. You get a mark for the correct substitution into that formula. And then you get a mark for the answer with the correct unit. Okay, that is how we mark. So I always encourage my learners, the second you get that question paper, in matric, your information page is actually a separate booklet within your question paper. The second you get your question paper, turn to the back, pull off the formula sheet. Done. Even if you absolutely know your formulas, have your formula page loose. It's always at the back. Have your formula page loose. Carry it through as you go through each question, okay? And double check that you are using the formula on the information page. Okay, it saves you marks. I know it might take a second, but the more you use that information page, the more you use the formula sheets, the better you get at using them. Okay, and by the time you get to matric, then it's easy. And then your teachers are all going to hate me for saying this. I don't care. When you answer a question paper, whether it is a test or an exam, ma'am, are we supposed to get a formula sheet in every exam and every test? Yes, Ms. P. If you're at a government school, I don't know about the private schools, what the IAB ruling is. The government schools, the rule is nationally in every test and every exam, you must get a formula sheet as well as the information page. I know some teachers cheat. What I do is I cut and paste, okay? So I take the formula sheet that you must be getting, and then I just cut the formulas that you need. Miss P, I know some teachers do that, and I know in maths, okay? I'm only speaking now for physical sciences. I can speak for maths. For mathematics, you do not get an information page or a formula sheet in grade 11, in grade 10 or 11. You only get an information page in matric. Okay. Yeah, but Cordley, last year you were in grade 9. And in grade 9, for some bizarre reason, you have to know the formulas off by heart. Okay, don't ask me why. I also have an issue with it. I give them. I don't care. Okay, guys, can I give you a quick problem? And you try it at home. Okay. Whoops. Right, so let's go for 2 cells. And we've got a potential difference there of 2,8 volts. That doesn't help me. Okay. It's like 6 minutes left. Don't be scared. You're going to get an extra resistor. Don't panic. Right. What is this? This is a series circuit. It has 2 cells in. The cells have a potential difference of 2,8 volts. It's got 3 resistors, 2, 3, and 5 ohm. So my questions are, I want the total resistance. I want the reading on ammeter. And it doesn't have a switch. That's fine. Oh, you guys are being difficult. Not all circuits have switches, especially when I build them. I just whack them together. Oh, thanks, Poppy. I'm practicing. I'm learning. Okay. So, guys, 3 questions. I want to know the total resistance. I want to know the reading. The reading on A, that A there. And I want to know the reading there on B. Okay. Let's see if you guys can quickly chalk it out. I want you to hold on to your answers. Okay? Don't shut them out. Get them ready. Okay? Just let everybody get there. Give everybody 5 minutes. Oh, guys. I look at you guys and I can only imagine you guys all in one big class. Like absolute pandemonium. And too much fun to teach, but I can guarantee you when you walk out of that class as a teacher, oh my goodness, I'm going to be the tiredest teacher ever. How you guys doing? You okay there? Okay, 2 minutes left. Ashley says she's ready. Sure. Wit warm. Mooi. Tyrese is ready. Corley's ready. Joey's ready. Poppy's ready. Brandon, where you? Oh, well done. Okay. What did everybody get for? Guys, ready? Okay, what did everybody get for number 1? Go, go, go. Tell me, tell me, tell me. I don't care if someone else got there faster than you. Len, I see that you've got your hand up. You need to use the chat function. Okay, so I can see everybody got Tyrese. Everybody got 10 for number 1. Super duper job, guys. Super duper job. Oh, Chumaling. You're also popping out. Okay, everybody got 10 ohms. Everybody happy with that? Right. Number 2. Go. What did you get? Yeah, yeah. Come on. Come on. Even if you think you're wrong, I don't care. Yeah. Okay, I agree. Okay, so we've got V here, and then we've got the 10 ohms. Okay, and then we need the current, and I agree with you guys. I also got 0.28 ampere. Right, the last one. What did you guys get for number 3? Ash got 0.84. Anyone else got answers? Come on. Number 3. Larissa got 0.8. Yeah. Okay, Carolina, I see where you went with that one. Cordia, I see where you went with that one. Tyrese, I see where you went with that one. Keys, like really? Whoa. Okay, right. I can see where you guys went wrong. Remember, it's okay that we make these mistakes. What did I tell you? I want you to make mistakes. You guys didn't look at isolating that section of the current there. So when you need to work out that voltmeter reading, you only look at the 3 ohms and its voltmeter, okay? And you know, we just work out that the current there is 0.28 ampere. Guys, you're not dumb. You have to make these mistakes. That's why I make you make them. Okay. What did I say? I'd rather have you make the mistake here than make the mistake in a test or an exam. Okay. Guys, I am super duper proud of you. We did series circuits. They're done. It's easy. It's cool. Tomorrow, what's the answer for V? Wait, 0.28 down 3. 0.84 volts. Okay, good job, guys. Tomorrow, we're going to look at parallel circuits. Only parallel. There's going to be no series in tomorrow. We're only going to do parallel. Okay. Guys, I am really looking forward to seeing you guys again tomorrow at 2. I love teaching you guys. You know that. And keys, no, I just wanted the 1 voltmeter reading. Well done, guys. Sure, this was impressive. Well done. Well done. Super job. Super job. Okay, guys, we got to call it because the next person's got to be on the next call and that you know. I will see you guys again tomorrow, 2 o'clock. Remember to log in a little bit early so we can chat away. And then I will see you guys again tomorrow. Thank you so much for joining. I hope you have a fantastic day. Bye.